that was a nice break. And we have one more page to go. So let's just finish. So number 10 says, explain the difference in the units for circumference and area of a circle. Okay. This is kind of like saying what's the difference between the units that you write for perimeter and what is the difference between perimeter and the area. So we know that perimeter and circumference, for that matter, is one-dimensional. And if it's one-dimensional, you don't have to write anything. We just write whatever the units is. It could be square. It could be feet. It could be inches. But we know that area is always two-dimensional. And if area is two-dimensional, you have to write the units squared. Whereas the one-dimensional units, you just write units. You just write feet. You just write centimeters. Area is always centimeters squared. The squared is kind of like it's the exponent. It's above the unit itself, and it represents that this is talking about space, right? Area is the space inside of an object, right? Perimeter is just the outer edge of the object. It doesn't matter what the object is, if it's a square, if it's a circle, the area is the space, right? That's why it's two-dimensional, because you have to do it by the length and the width, or in this case of a circle, you do the radius times the radius, okay? So the area of two objects is given. Calculate the radius of each object's surface to the nearest whole number. Okay, so this is where we have to use inverse operations class. We know that by definition, the area of a circle is pi times r squared. So if they give us the area, 3.14, which is kind of a funny number to use, then we know that 3.14, which is the area, is going to equal pi, which is 3.14, times r squared. So all you have to do is divide both sides by 3.14, and you end up getting r squared isolated. What's funny though is 3.14 divided by 3.14 is 1. So that means what times itself will equal 1, right? R squared equals 1. There's something that we call the square root, and we just apply it to both sides of the equation, and we get r equals 1, and this is inch. Okay, so let's recap what I did. I took my area, which was 3.14, and I set it equal to the formula of the area, which is pi times r squared. Pi is always 3.14 in this case, and what's funny is the area itself is also 3.14. So I then divided both sides by 3.14, and I got r squared is equal to 1. So it's like asking what times itself will equal 1, and the only value is 1. Okay, let's try another example. Maybe this one will make a little bit more sense. So we know that the area is 50.24. So I write 50.24 is equal to 3.14 times r squared. Okay, same exact setup. So now I divide both sides by 3.14, and I'm going to get r squared is equal to, what is 50.24 divided by 3.14? That's exactly what I thought it would be. R squared equals 16. So now you have to ask, what times itself, what number times itself will equal 16? Square root both sides, and you realize that r has to be 4. 4 times 4 equals 16. Okay. If at any point you need to pause the video and go over the entire problem again, that is the beauty of online learning, right? You can always pause, you can always go back. Also, if you have a question about what we're doing, please see me during office hours. I'd love to go over it with you. We can have more practice problems like this. It's exactly why office hours are very, very helpful, class. So I do hope to see you there. I'll be posting these lesson notes online. This video will be online, but obviously live Q&A sessions also help. Okay, 2 more problems to go. It says start with the formula, show your substitutions, and solve. Write your answer in a complete sentence. Round your answers to the nearest hundredth where appropriate. Okay. A certain earthquake was felt by everyone within 50 kilometers of the epicenter in every direction. What is the area of the earthquake? Okay. So an earthquake was felt 50 kilometers of the epicenter in every direction. So you can kind of say like, wow, this earthquake was hitting from the center. It was going 50 km everywhere. Well, that's like saying that the radius was 50 km. And if we know the radius, and we also know that the formula of area is A times pi times A equals pi times R, well then, don't we know that the area has to be 3.14 times 50 times 50? It's a really, really big earthquake. But 50 kilometers is, wow. 50 kilometers, 1.6 kilometers is 1 mile. So 50 divided by 1.6 meant that the radius of that earthquake was 31 miles. That's a huge earthquake. Or maybe earthquakes are usually that big. I'm not sure, actually. But let's calculate the area of this earthquake. 50 times 50 times 3.14, and that gives you a total area of 7,850 kilometers squared. Okay, so really, class, it's not that bad, right? If you're given the radius, all you have to do is plug it into the formula. Obviously, we know that pi is 3.14, and this calculation is all done by a calculator. So you just have to set up the problem, and you would say the area of the earthquake was 7,850 kilometers. Okay, let's finish. A circular pond, 12 meters in diameter, is surrounded by a brick walk 3 meters wide. Find the area of the pond and find the area of the walk. Round to the nearest hundredth. This is an epic question. It's kind of challenging because it's a little bit intimidating, but let's just draw exactly what they're saying. So a circular pond has 12 meters in diameter. One thing we realize too, class, is we don't want to use diameter for area. So instead of saying it's 12 meters in diameter, I'm going to write that the pond is 6 meters in radius. Okay, so we know that if D is equal to 12 meters, R is equal to 6 meters. So we could definitely calculate the area of this pond right now. Okay, let's go ahead and do that. So let's do the area of pond is going to equal pi times 6 times 6. Right, so the area of the pond is going to be 36 times 3.14, which we've calculated in this lesson already, but it's 113.04, and it's meters squared. Okay, so there also is this outer edge, which I'll use another color for, and it's a walkway. So it's kind of like the It's the outer walkway that kind of borders the entire pond. And they're wondering, what is this kind of like onion ring looking area? I mean, if that looks like an onion ring to me, but what is the area of this onion ring, right? What is the area of this walkway? Just this space right here, this space right here. Well, there's no formula to calculate that, right? But we do know, class, that if I were to calculate the entire circle, including the pond, the entire circle, what would the radius be? Well, hopefully you're starting to realize that the entire circle's radius is 9. So the entire circle radius is 9 meters. So if I take the entire circle, class, and then I subtract the area of the pond, the inside circle, doesn't that mean I will get the outer edge? Okay, so I'm going to write this. Entire circle area minus area of pond. That's going to give me the area of the walk. This walkway, which is I've kind of shaded in green, I'll also shade in purple. That walkway is the entire circle's area minus the area of the pond, and that will equal the area of the walkway. So we already calculated the area of the pond. Now let's calculate the total area of the entire circle. The entire circle has a radius of 9. So that means the area is pi times 9 times 9, which equals, that's 81 times 3.14. That's 254.34. Okay, still not done though, because that's the entire circle. So we know that the entire circle's area is 254.34. All I have to do now is subtract the 113.04, which is going to give me the area of the walkway. And then I get a final answer of 141.3, and this is meters squared. So you'd say the area of the walk is 141.3 meters squared. Yeah. That was a tough question. You definitely want to review. I'll review one more time. They said a circular pond has 12 meters in diameter. Okay, so if it has 12 meters in diameter, that means the radius is 6. And just off of that piece of information, I was able to calculate the area of the pond. Pi times 6 gives me 113.04. They also said that there is an extended walkway from the circle that is 3 meters wide. 3 meters wide. So drawing the picture, you start to realize, wow, this entire circle has a radius of 9. If you take the entire circle's area and subtract the area of the pond, the inside circle, you will then get this outer edges space, this part. So all you have to do is take the entire circle's area, which is a equals pi times 9 times 9, and then subtract it from the area of the pond, which is the area inside, and then you will get the area of the walk. Okay? Great job, everyone. Take care.